So, welcome to this webinar about skeleton streaming into Unity, and it will actually be a little bit crash course in Unity together with real-time data from Qualsys. We'll go over a bit of concepts and so on. Doing this webinar is me. My name is Martin Holmberg. I'm doing business development for the entertainment area, so animation and virtual reality, even though I'm probably here more as my previous role as a mocap specialist and a Unity guy. And to help with answering questions and so on is Johannes Kotlén, who's one of our software developers. He's one of the guys who's writing code in QTM, and he has a background as a Unity developer, so he knows way more than I do actually about Unity and coding. A few tips before we go. For the webinar control panel, there is a small orange dot that you can kind of expand and detract it. You can go to full screen so that you see everything better. And also a tip is to go to audio settings if you can't hear me and select computer audio, which makes no sense to say if you don't hear me. If you have any questions, if you want to give us feedback and so on, there's a questions pane where you can view and enter questions, and Johannes will help you out and answer them. And if there is kind of general questions, he will just signal me and I will answer those for everyone. Yeah, sound check, sorry. So the agenda for today is we're going to check out how to install or import, as you would say in Unity language, the ktmconnect for Unity. We're going to explore the concepts of streaming data from QTM to Unity. What kind of data can you stream and how can you do it? And then we're going to have a look at streaming skeletons. We're going to apply them to a Q avatar. We're going to have a quick look at analog data that might be interesting. How to stream 6DoF bodies and connect them to get the data for that onto objects, and just a quick tip on how to make a virtual camera. I'm not going to run this in real time, so I'm going to fake it with our real-time stream from file. So I can't really demonstrate the virtual camera, but I will show you the concepts so that you can easily do it yourself. So starting off, there we go. Starting off, our ktmconnect for Unity, it's an open source library. We do appreciate all pull requests on it. So if you do make changes, if you make improvement and smart scripts and so on, just add it to the repository and make a pull request, and we'll happily add it and credit you for it. You can download it at GitHub. You have to find the releases tab, so you don't need to download the code. So you can actually download it as a package, and the address is GitHub and Qualsys. So let's jump to that. I usually just Google it. So we come to our Qualsys GitHub. So it's github.com/Qualsys. Under this we have a bunch of repositories. Our basic idea around open source is everything that is outside of QTM. So we keep our QTM source code proprietary, of course, but everything that is outside of that, we want to be able to share. We want you to be able to see the code and see how it works. So there's a bunch here. On the top is the Qualsys Unity SDK. And to download the Unity package, you just go to releases. So let's see again. So you have releases over here. You click that one and you just download the latest package, and you can find that over here. So Qualsys Unity SDK package, Unity package. Just click that one and it will download. It's 100 megs, so it's quite quick. Now when we got that one, we're gonna open up our Unity application. I do recommend you to use Unity Hub. It's nowadays hard to use Unity without Hub, but it's really nice. And then we just create a new project here. I already had that, so webinar external or something. When you create a Unity project, there is a few templates. I usually go with a 3D with extras. So you have a 2D, which is just if you're going to do a control menu or 2D application, you have the basic 3D, and then you have 3D with extras. What's good with it 3D with extras is that you get a more advanced render pipeline included from start, so you can make things look a little bit more pretty. You also have the high definition render pipeline. It's a little bit harder to work with. Many assets that you just grab from the asset store won't really look good without working on the materials and so on it. So my recommendation is start with a 3D with extras. It's kind of nice. So there we go. While this loads, we do need some QTM data to work with, and I'm going to grab that. We have our Qualsys file library where we have lots of demo files. You will find that by going to qualsys.com and clicking demo files. That will get you to the Qualsys file library. Since I want to have something with a skeleton, I will just write skeleton in the object, and we want the animation marker set because I like entertainment, play mechanics. And in here you have a project file, so you can just download that and get all the files. So let's see here if Unity wants to wake up. Here we go, and we have our Unity sample scene that you will always get. Also handy is that you would get a small camera script for moving the camera around in this project. So this is the scene that we have here, but I'm going to make a new scene. So we open up the scenes folder. A good tip is to try to keep it a bit organized where you put stuff, because it will get messy quickly if you just put everything in the root of the asset folders. Anyway, I'm creating a scene here, so right click and create and scene, and let's call it webinar, and this gives me an empty scene, just completely empty. Now the first thing we need to do is to import our QTM package. And there's multiple ways of doing this. You can go to assets and you can import a package and a custom package. But the handy way of doing it is just to go to your download folders or wherever you have placed your the package that you downloaded, and just drag and drop it. And then you drop it into assets. And then it thinks a little bit, and then it shows everything. There's a few QTM files in this package just for demonstration, skeletons and so on. So if you want to keep down the size of your project and you're not going to use the demo assets and so on, you can uncheck them here, and then you don't have to have them inside of your project. I'm just going to import everything basically. So there we go. It will work a little bit. While we do that, I'm going to jump over to my my downloads and already had them, so I'm overwriting it. So I'm just extracting my the project that I downloaded, QFL skeleton solver, and double-clicking settings to open up the project. And let's turn off QTM first. Double-clicking settings actually drops me into QTM with that project. It's kind of a neat way of opening projects. And here you can see on the right, I have Sten doing acrobatics. It's our machine learning guy who's also an acrobat. There's a room and acrobatics, and then it's two of his cheerleader colleagues who's doing some dancing. So I have a few QTM files here that we can look at. I've also added some 6.0 files here, the T5 and the T6 flight, which is just so that I can show you some 6.0 data. Also, jumping back into my project here, you can see that now I have my Qualsys assets. They're placed in the Qualsys folder. Just having an overview here, we have demo assets, and then we have the QTM Unity real-time streaming things, where we have the streaming folder. This is where the scripts that you will actually use are located, and the RT client SDK.net. That's the same code as we have in our RT client, so there's no DLL that is imported. You have access to the whole source here if you want to go back and see if you want to do something differently than we do it. So next, let's start off with adding a skeleton and streaming that. First off, selecting a file in QTM. Let's go with Eli's Rome here. So we go play, and as you all probably know, under play you can play with real-time output. This will fake it as we would be in real time. So the real-time server is on. It makes all the data available on the real-time interface. Quite neat to use. So now we have a skeleton. We're going to show our Qualsys window here. So window. Qualsys RT client. This gives us a panel where we can actually turn on and off streaming and so on, and what we want to stream. So if I just press play here now on my empty project, you can see that I found some QTM servers, and we're going to connect to our local host, so this computer. And then we connect, and it will actually show us that there is a few available skeletons. Mike and Eli is available, and there is no channels available, so no analog data since I don't have any analog data. Perfect. Let's get this onto data onto a avatar. Now, first off, I'm just going to create a plane so that we have something to stand on. I'm going to do this 10 by 10 meters, and we can actually grab a material here from I thought I could grab it's under example assets. We just grab material from the example assets. So we have a plastic white, and then we're also going to have our main light. They always make it so very yellow in Unity, so I'm just going to do it white instead. Weirdly enough, that's something they do. So now we have a plane, something to stand on. It's located way off, so let's put it then 0, 0, 0. So we have the plane just in the middle. So basically we put the floor down. We're going to grab from our demo assets, we're going to grab our Q avatar and drop it onto it. So this is our Qualsys avatar. that we have made. It's a good starting point. And then to now it's actually suggested this, but then we're going to add a component which is the RT skeleton streaming. So we can do that multiple ways. We can go into streaming and we can take the RT skeleton here and we can drag that over to our QAvatar. So now we have an RT skeleton script onto this one. On this we have to put the name of the skeleton that we have. So if we jump over to QTM here, we can display skeletal data. And we can check which one is it. So it's Eli that we have data on. So then we're going to jump back to this one. We put Eli as the skeleton, and the avatar is it's the skeleton, the human pose that is connected to the. So each the FBX should have an avatar inside of it. If it hasn't, you have to create that automatically, and it needs to be a humanoid avatar. But for now, QAvatar avatar, and oh, a good tip, if you make changes while in play, that won't be saved. So this is really good because now we got a nice do it again thing here. So first off, we create a plane, we put it at 0, 0, 0, we put it 10 by 10 meters, and we go on material and example assets, materials, white plastic floor, change the color of the light. There we go, and we jump into the demo assets. We drop on to this one, a QAvatar. We add a component to this one, which is the RT skeleton. We put the name of Eli to it, and we put the avatar QAvatar. There we go. So if we press play now, we want on this camera, we just want to add a component, simple camera controller. This gives us the same camera controllers as we have in the editor. So it's kind of nice to just be able to fly around. If we then connect to the QTM server, we should have skeleton moving, doing a range of motion with a little bit of weird shoulders. Sorry about that. We're going to update the project with a better solve. We'll fix that actually. So now we're streaming skeletal data. What if we want to stream 2 persons? So let's try to do that. So we turn this off again. We take a Eli and Joe dance instead. Press stop. We go Eli and Joe dance. We go capture, and now we go play and play with real-time output. So what we want to do now is we want to just copy the avatar or drop another avatar in. We can actually name this also. So we have Joe and we have Eli. In Joe, we're going to have the skeleton named Joe instead. And both are pointing to the QAvatar avatar. Yes. So, and all of a sudden we have 2 people dancing. You might have noticed that I have to press my connect button all the time. So let's fix that. Let's add a small script that connects us automatically. So auto connect. So now we're adding a small script. This is to show you a bit about about the scripting here. So we're going to open up this one just to see how to access the script. You don't need Visual Studio for this. Visual Studio Code works perfectly. So to do this, I start by calling on the Qualsys Realtime Unity package, and put a placeholder for the RT client. And then the first thing I'm going to do is I'm going to take my RT. There we go. So I'm going to fetch my RT client. So what I do then is I go from the RT client and then I get the current instance that we have. So I'm populating that one with the current one, and then I use this one to do a connect. So I do my RT client and then I can do a connect, and I connect to whatever IP address I want to have. In this case, I'm just going to do it on my local host. Made something wrong. Okay. I need to say all the streaming stuff I want to do also. I don't want UDP. I want to stream everything now. Was that enough with truths? No, for 10 arguments. There. 1, 2, 3, 4, 5, 6, 7, 8. One too many. There we go. So if I now press play on this one, I got an error. I did some kind of mistake on this one. Probably the UDP port. Let's just select the port. Connect to more or less anything. This worked really good on the preparations. Don't really know why. All right, so that's basically how AutoConnect script is gonna look like. I'm actually gonna cheat a bit. I prepared a bit better AutoConnect script, so let's drop that here into. Now we just have to wait for Unity to get that. I'm going to check the questions while we wait. So there's one question if it's possible to adjust the avatar dimensions, and yes, you can scale it. So you can scale it on, you can go more or less advanced on that one. Oh, my Unity has died. You can be more or less advanced. You can of course scale it on just normal scale, or you can rescale the whole model if you want. We are using a retargeter, so it doesn't really matter how big your person inside of the thing is. And we lost all our changes due to the crash. Perfect. So we are jumping forward a bit. We are dropping our AutoConnect script here, so we get the working AutoConnect. We add that to an empty object that we call connect. We add a component, and we use our AutoConnect script here. No, that's a bad AutoConnect script. Okay, let's skip the AutoConnect script. I'm going to supply it while I fixed whatever went wrong in this import thing. So if we delete that one, now we just have one. We'll live without the AutoConnect script for now. The next thing I wanted to show you was the real-time streaming of 6DoF bodies, and that's very, very easy. We're going to change to something where we have, in this case, a plane flying around in a kind of huge area here, but it's kind of nice when it's big volume. We're gonna put the plane on it again. We're gonna place it at 0, 0, 0. There we go, and we're gonna make it 10 by 10 meters. Starting to learn this now, I think. We're gonna put the material onto it, plastic white. So, and the white light. Next thing, we're just going to add a 3D object. Let's do a cube. Let's place that one also in somewhere in the middle of the scene here where we can see it. And to get movement onto this one, it's very, very easy. So what you do is you grab from the real-time streaming, you drag a RT object script onto it. So when you drag RT object onto it, you will get this setting. And here you just need to place the name. So, we're going to have a RT object markers is not what I want. I want to RT object onto it. Let's go with that one. There we have it. Sorry about that. There we go. The RT object is what I want, and it's called plane. So let's call it plane, and let's save this scene. So now we saved it. So for the next crash will be all right. There we go, and we press connect. Let's see where it went. So it's over here flying. So basically, this is all you need in the settings for the cube or for the RT. You can have a position offset, so you can move the object in relationship to the data from Qualsys, and also a rotational offset. What if you want to do this with a camera? It's actually as simple as that. What you do is you take the camera, and it's important that you don't have any camera scripts on it. I mean, scripts that move the camera around, like the simple camera script that I showed you before. You drag the object onto it, you select, and it's still play, and you press play. And we don't have how to connect, so let's do this. And here you can see we are moving our camera. So if we go to the scene, you can see that we have the camera. And then you have to figure out what's forward and so on, but it's just a question of what's going forward. If you just drop it onto it, you can see that it's -Z in Unity coordinate systems, which would translate to a -Y in, or actually a Y in QTM coordinates. So what I do is I just put markers onto an iPad or a laptop computer and place the origin of that one in the center of the screen and align it to that, and then you have a virtual camera. Very simple. It's kind of neat since it compiles to Android or iOS or anything. It's very easy to do a virtual camera. Next up, I wanted to show you a bit of how to get data from QTM or from a skeleton onto labels. In this case, is basically what I'm going to do first. For that, I'm going to do this. Add a UI element, and I add a canvas. Just so we have something to draw on, and then on this UI I just add a panel so we can have a bit of gray background. So I add a panel. I do a dark color onto it, and I want to have it connected to the upper side. So I hold in Alt and Shift, that places it and everything in that corner, and then I make it way smaller. We want to have it maybe 200 pixels by 100 pixels, something like that, and have a little bit of distance from the end. There we have it, -10. There we go. Now we have a panel for our labels, and in this panel I just add text field. I want to place that one also up in the corner, maybe 5 pixels away from the border, and I want to make it white. There we have the color, white text. So now we have a small label list thing. To do this script, there's multiple ways. I can, of course, just add a script to my text component, but then I have to add a script to each text component. So let's just place an empty object, call it text script or something like that. Onto this one, I add a script. So in this case, I want to have a new script, and I call that the most difficult thing is always to name variables and scripts. So we call it text script. And what we want to do with this one is we want to print knee angles from the avatar. So let's just quickly drop in our Q avatar again. So that one is with us with a big box on the head. We want to add a skeleton script. We want to have Eli on it, and we want the avatar to be Q avatar. Just a quick question, Johannes. Do you see the questions? So you can answer them under questions. Here we go. And now we have, if we press play now, and we connect, we let's not use this one. So we go with a Rome here, Eli's Rome. There we go. So now we have a skeleton moving. We can check in the game and pause this one. In this one, we disable that RT object, and we put a simple camera controller onto that one. There we go. Now we can actually see what she's doing. And for this text script now, how do we do that? Well, we need to know what we're going to print and where we're going to print it. So let's open up this one and give that one to game objects input. So we do a public, so we have something we can add, and it's a sometimes when you have to restart Visual Studio to get syntax highlighting in or IntelliSense in your Visual Studio thing. Can be a good tip if you're sitting there wondering why nothing is working. There we go. So we want a public game object, and this is text object. Good to know is for each capital letter that you have in your variable name, it will actually make that a new word. So, and so we have two game objects. We have a text object and a skeleton object. And what we just want to do on the update is we want to take this text object, and then we want to get the text component of that one. So we just go text. We need Unity engine.ui to get access to those. There we go. And we want to have the text object on the component in this text object of the text object. And then we just want to have the text on that one. There we go. And we just want to set that to the skeleton object, and the transform of it and the local transform. So we get, for example, if we want to have the knee angles, we just want to have the local rotation from the skeleton object, and we want that in Euler angles, and we want to have it to a string. And since we don't specify which angle we want, we're gonna have an array, but we're very happy with an array. So let's see if it can compile this one. Yes, and on our text script now we have two fields where we're going to drop stuff. So we drop a text on that one, and we drop whatever we want to have. We want to have a knee angle, so no, left up. So left leg is good. So left leg is the lower leg of that, and it's the local component. So it will be the knee rotation. Worth noting now is that this is the angles of the, let's see what happens if it works. This is the knee angles of the avatar. So it's the knee angles after. Okay. Did I make a mistake here? Yeah, that won't work. There we go. So, so this is the knee angle of the retargeted skeleton. So if we want to have the knee angle of the skeleton, so if we look here, what we do is in the Q avatar, we have the reference skeleton. This is the skeleton that controls the mesh. So this is the bones where the mesh is connected to. When you start your streaming, we will put on our QTM skeleton, which is called Eli in this case. And this is what's going to be retargeted by mechanism into the reference skeleton. So there is a retargeting thing here. So these values might not be the same values as you have in QTM. What you could do is you could draw the Eli left leg onto this one. This will now be the angles that comes from QTM, but since these are dynamically generated, you can't do that in the editor. So you would need to search for that one. So basically, instead of having skeleton object here, you could search for skeleton object or search for the game object Eli left leg. Just a tip, depending on which one you would have. So basically, just maybe I should show you that. It might actually be handy. So let's jump into this text script again, and instead of this, we go with a public string that is skeleton name instead, and add a if case here. If skeleton name is equal to null, then do this what we did before. Oops. Oh, this is really hard. Do what I want. There we go. Else we're gonna go with a game object dot find skeleton name, and from that just go with the transform again, the local position, local rotation in Euler angles to a string. And of course we need to assign that one. totally lost now. Game object, there we go. So instead of grabbing the object name, we are finding an object with the name of the skeleton name. Let's see if this works. Let's correct this one so it's correct again. We're going to have left leg onto the skeleton object and the text object there, and press play. Connect again. There we go. Here we have the connection, and let's see if we now change that one to a text. So let's change it to something really easy. Eli underscore ips. Now we find that data instead. So we can have Eli. Copy that Eli left leg thingy again. So now you can see the values of that, and that should be the same values as the Eli left leg. So if I remove that, it should be the same in theory. So we have a bunch of questions. So we have one question, if it's possible to add more bones to the real-time skeleton, and yes it is, and we're actually going to add finger to our skeleton so that you can drive that also, but that is in a future release. We do have a little bit of special ways that we might help you with that. So for that, I would actually recommend you to send an email to support, and I'm going to help you with that. So how does real-time streaming work with VR headsets was another question that we got here, and it's basically the same. The only problem is that it depends on the VR headset that you have, if it accepts overriding the position. Oculus works very well. The Vive you do have to go via the OpenVR driver. If you have a Vive, send us an email and we can give you our OpenVR driver. And then you need to do a little bit of fuse between the rotations, because you don't want rotations from the mockup system, you want rotations from the headset and so on. So it's a little bit tricky. Hopefully we'll have a webinar on that separately. And another question was, does the real-time streaming still work after compiling or building the Unity application? Yes, of course, but this you won't get this panel, so you have to use the auto-connect script that I will distribute. It worked really well when I prepared the webinar, and it didn't work when you can write it. A problem is the port number on the connection. It's probably as simple as that. Also, there's a question, are these systems applicable to various sports sciences? And yes, it definitely is, especially with our new sports marker set, which calculates the joint positions a little bit better and a little bit more angled towards biomechanic uses. So basically with this, you can easily create your own visual feedback system. So if I wanted, I could add a typical application that I would do with this is if I do a squat, for example, just look at the knee angle, and then you just go green screen when the knee angle is whatever value is kind of acceptable for a good squat. So for example, if you have yeah, well, the squat should be 90 degrees in angle. I don't know if that biomechanically correct, but as an example, you want 90 degrees on your rotation. Then just goes green screen. And then you can have a visual feedback on when their squats are good or if they were too low or too high and so on. So it's very applicable, and it's actually quite easy to write nice and easy real-time feedback loops for this. So I hope that the time went by like way too fast, as it always does. So I would like to say a big thank you from me. And if you have any follow-up questions, use the support email, and support people will tag me, and I'll help you. And it's also possible to do some one-on-one stuff if you're interested in special cases and so on. So just shoot us an email if you have any questions. I do have to do a little bit of advertising also. We do have a new webinar coming up. It's the 13th of April, and it's Irvin and Lars who's doing a real-time mocap with ktmconnect and SDKs. So it's getting data into, I think they said MATLAB, LabVIEW, and Motion Builder. I added a Python because I thought that was that. And to find out more about these and old webinars, you can just jump over to Qualsys.com. And I think that we have a nice link. Maybe not. So go to qualsys.com/webinars. And here you have the webinars, and we have an upcoming webinar, real-time mocap with ktmconnect. Listen in on that one, it's really cool. So hope that everyone got a little bit of inspiration. It's very fun to work in Unity, it's very quick. There was a question about, can you do streaming in editor mode? And though it's theoretically possible, the setup of Unity differs a bit from the setup of Unreal, so it doesn't really make the same sense to have your streams in the editor. But it's I mean, it's you can do it, but it's not as natural as the in editor mode in Unreal, where in editor mode is basically you press play but you're still inside of the Unreal environment. So big thank you for me. If you have any more questions, I'll keep the stream open for a bit, and I'll go over the questions and see if I can address them. If you have any other questions, send an email to support. So it's support@qualsys.com. Maybe I should write that somewhere. Or go to qualsys.com, and here you can see all the stuff. One last thing before you leave, Q Academy has really good tutorials on this. So you have a how to use ktmconnect for Unity, and also the material from this one will be available on the web page. I'll include a Unity project with all the stuff that we did, working scripts and so on, not buggy scripts, so that you can see and review what we did. So big thank you from me and Johannes, and it doesn't seem to be that many more questions. So there's one question on advanced methods for avatar scaling. Well, it's basically if you open up the avatar in Maya or Blender or your 3D tools, you can actually rescale it there and rescale the bone rigging, but then it starts, you kind of need a 3D artist or a rigger to do that, but that would be the advanced way of doing it. The normal way is just to scale the avatar inside of Unity. So to show you how to do this, there is a scaling here, so I can make it 0.9, 0.9, 0.9, just to get the head at the right position. And if you want to do it automatically, you can always just add a script to it, check where the position of the head is, and then with the position of the head, you can kind of approximate how tall is the person, and then just get the scale factor onto it so that you can get the scaling down on it. So thank you very much, and thank you for attending. It's been amazing to do a webinar here.